Hello everyone, welcome to PHARMA GLP. In this video, we will discuss detector calibration parameters as per IP guideline. For calibration of detector, the parameters are detector linearity and wavelength accuracy. For both these detector calibration parameters, the chromatographic conditions and mobile phase are same. So, first we will understand how to perform detector linearity. Before starting with detector linearity, let's understand what is difference between detector linearity and injector linearity. In detector linearity, the injection volume is kept constant and the concentration of caffeine standard is changed, whereas in injector linearity, the concentration of caffeine standard is kept constant and injection volume is changed. To perform detector linearity, we require hplc grade water, hplc grade methanol, C18 or C8 column, caffeine standard, analytical weighing balance, and glassware such as volumetric flask, pipette, and beaker for dilution. First, prepare mobile phase same as injector linearity, that is, by mixing equal volume of hplc grade methanol and water in a ratio of 50:50 volume by volume and degas for few minutes to remove air bubble from the mobile phase. Now, set the hplc system using chromatographic conditions such as column is C18 or C8 having 250 mm length, 4.6 mm inner diameter and 5 micron particle size. Mobile phase is methanol and water in a ratio of 50:50. Flow rate 1.0 ml per minute. Injection volume 10 microliter. Detection wavelength UV at 272 nanometer. Runtime is about 10 minutes. The expected retention time of caffeine peak is about 5 minutes. After that, we have to prepare detector linearity solutions. For this, accurately weigh about 100 mg of caffeine standard in a 100 ml volumetric flask. Dissolve in a 10 ml of methanol, make up to the volume with mobile phase. This will give 1000 ppm stock solution. From this stock solution, further dilute accordingly with mobile phase to get solutions having concentrations of about 0.001 mg per ml, 0.01 mg per ml and 0.1 mg per ml, that is 1.0 microgram per ml, 10 microgram per ml and 100 microgram per ml respectively, or else we can say 1 ppm, 10 ppm and 100 ppm respectively. To simplify this, first we will understand how to convert mg per ml value into microgram per ml value or ppm value, and then we will understand how to make dilutions to prepare linearity levels so as to achieve these concentrations. 1.0 mg per ml can be converted as 1 mg in 1 ml, that is 1 divided by 1 into 1000 corresponds to 1000 microgram per ml or 1000 ppm. Now next is 0.001 milligram per ml can be converted as 0.001 mg in 1 ml, that is 0.001 divided by 1 into 1000 corresponds to 1.0 microgram per ml or 1 ppm. For 0.01 mg per ml can be converted as 0.01 mg in 1 ml, that is 0.01 divided by 1 into 1000 corresponds to 10 microgram per ml or 10 ppm, and for 0.10 mg per ml can be converted as 0.10 mg in 1 ml, that is 0.10 divided by 1 into 1000 corresponds to 100 microgram per ml or 100 ppm. Now coming to our detector linearity level, as our stock solution is 1000 ppm, so from this stock solution we can prepare our linearity levels using the basic formula N1V1 is equal to N2V2. Let's consider our first level, that is 1 ppm solution. In this, N1 value is 1000 ppm, V1 value in ml we need to calculate, then N2 value is 1 ppm and V2 value is 100 ml. So we can calculate 1000 into V1 is equal to 1 into 100. This can be further calculated as 1 into 100 divided by 1000 will give 0.1 ml. So using this formula we can calculate our remaining levels, that is 10 ppm and 100 ppm. Based on this calculation we can prepare our linearity levels as for 0.001 mg per ml or 1 ppm solution, take 0.1 ml of 1000 ppm stock solution into 100 ml volumetric flask and dilute with mobile phase. For 0.01 mg per ml or 10 ppm solution, take 1 ml of 1000 ppm stock solution into 100 ml volumetric flask and dilute with mobile phase. And for 0.10 mg per ml or 100 ppm solution, take 10 ml of 1000 ppm stock solution into 100 ml volumetric flask and dilute with mobile phase. Allow the system to stabilize, then inject blank solution as mobile phase and then inject in duplicate 10 microliter of 0.001 mg per ml, 0.01 mg per ml and 0.10 mg per ml, or we can say 1 ppm, 10 ppm and 100 ppm solutions of caffeine. Record the chromatogram and from the obtained data plot the graph of mean area counts of duplicate injection on y-axis versus concentration microgram per ml or ppm on x-axis and calculate the value of R square. The acceptance criteria is the R square should not be less than 0.990. Now our next parameter is wavelength accuracy, in which first is wavelength accuracy for photodiode array detector, that is PDA detector. For PDA detector, set detector wavelength at 200 nanometer to 400 nanometer. The caffeine solution of 0.01 mg per ml concentration is injected for entire range such as 200 nanometer to 400 nanometer and detector response is recorded. Set the hplc system using chromatographic conditions same as detector linearity. Inject blank solution as mobile phase and then inject 20 microliter of 0.01 mg per ml solution of caffeine. Record the spectrum and report the maxima and minima. The acceptance criteria is the wavelength maxima found should be between 273 plus minus 2 nanometer and 205 plus minus 2 nanometer and the wavelength minima found should be between 245 plus minus 2 nanometer. Now the next is wavelength accuracy for variable wavelength detectors, that is VWD detector. The caffeine solution of 0.01 mg per ml is used and the test is performed for different wavelengths such as 205 nanometer, 245 nanometer and 273 nanometer. Set the hplc system using chromatographic conditions same as detector linearity. In this, create 32 acquisition programs with same parameters except change in wavelength at the interval of 1 nanometer each and the sequence is run for each wavelength. That is, for 205 nanometer, the wavelength ranges from 200 to 210 nanometer. For 245 nanometer, the wavelength ranges from 239 nanometer to 249 nanometer. And for 273 nanometer, the wavelength ranges from 269 nanometer to 278 nanometer. Inject blank as a mobile phase and then inject 20 microliter of 0.01 mg per ml or 10 ppm caffeine solution and sequence is run for each wavelength and detector response is recorded. Record the chromatogram and report maxima and minima. The acceptance criteria is the wavelength maxima found should be between 273 plus minus 2 nanometer and 205 plus minus 2 nanometer and wavelength minima found should be between 245 plus minus 2 nanometer. That's all for today's video. I hope this is useful. Thank you for watching and see you in the next video.